So let's take a look at this example. So we have 5x minus 5 is equal to 4x plus 7. So I'm going to go through my 5 steps. Even though there's always 5 steps to every equation that you solve, but as you've already seen, you're not always going to have to use every step. So let's go back and let's take a look at what those steps are again. So if you go back to your notes, and the first step is to get rid of parentheses. Well, if I'm looking at this problem, do I even have any parentheses, any grouping symbols? And so the answer is no. Okay, so I don't have to worry about getting rid of any grouping symbols. So I'm going to move on to step 2, combine like terms. Now I'm looking at this problem and you might think that 5x and 4x are like terms. And yeah, in a way they are, but also they're not. Okay, so Ms. Greene, what the heck are you talking about? Well, if you go back and you go back to what we talked about before with the word expression, treat each side right now as an expression. So 5x minus 5, does this expression have any like terms? The answer is no. 4x plus 7, does this expression have any like terms? The answer is no. So I don't have to worry about combining like terms because there are no like terms. So let's just take a few little notes here because sometimes I forget that we're doing this online and not in class. So step 1, get rid of parentheses. So we're going to say in that step that it is not necessary. Okay, step 2. I'm going to call it CLT for short, combine like terms. And I'm going to say not necessary. So that brings us down to step 3, variables on both sides. So do we have variables on both sides? And the answer to that is yes. We have a 5x here and a 4x here. And we need to get those variables together. So step 3, variables on each side. So I'm going to go ahead, write my problem out. And at this point, because we have variables on the same side, we need to get the variables on the same side, this is where we're going to be drawing that line because we're going to be crossing the bridge. So I need to either move the 5x over here with the 4x or the 4x over here with the 5x. It doesn't matter which one you move, but I try to avoid negatives if possible. Also, my brain likes to work from left to right, so I always like it when the x is over here. Not that that really matters. So what I'm going to do is I am going to move this 4x over here with the 5x. So to do that, remember to make it go away here, because it's a positive 4x, you're going to have to subtract it from the 5x. Cancels out. So 4x from 5x leaves me with x. x minus 5 is equal to, bring down your 7. So now I'm ready to go on to step 4. So I have x minus 5 equals 7. So step 4 says, do we have constants on both sides? Well, if you remember, a constant is a number without a variable attached to it or without a variable beside of it. So the answer to that is yeah, we do. So step 4, I'm going to say constants together, or constants on the same side. And so for that one, I'm going to move the -5 over there with the 7. To do that, I have to add the 5 to the 7. And so now I have x is equal to 7 plus 5 is 12. Now, the last step, step 5, says to divide or multiply, or undo division or multiplication. Well, if I look, there's nothing to divide or multiply by. X is by itself, so step 5 is not necessary. Because x is isolated. And so our final solution is 12. The value of x is 12. Remember, our whole goal is to find the value of the variable or to find the value of the unknown. So we're done. We know what x is.